Here are our detailed solutions to the second sample mastery test. All right, for number 1, we have negative 2/3 raised to the third power. What you need to remember about that is that means that we're going to multiply negative 2/3 times itself and then times itself again. There are 3 identical factors there. First off, negative times negative times negative is a negative, and then 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. So final answer, negative 8/27. Number 2, 2/3 to the negative 3. Different now because the exponent is negative. Remember that when we raise a fraction to a negative power, we take its reciprocal, and then we raise it to the positive power. So that means 3/2 times 3/2 times 3/2, which is 27/8. Very different results. All right, let's check out number 3. Any number raised to the 0 power is 1. In number 4, we have to follow order of operations, which means exponents need to happen first. So 9 to the negative 1 is 1 over 9 to the 1 power, or 1/9. And then 4 times 1/9 is 4/9. So now we need common denominator. So 9/9 plus 4/9 is 13/9. Final answer. Improper fractions are good. Don't feel the need to change it to a mixed number. Right, in number 5, we're asked to write an algebraic expression using the number variable x to represent the number described. So twice the sum of a number and 6. So that means we're going to take twice of the result of the sum. So the sum of a number and 6 is that number plus 6. Now if we're going to multiply it, we have to multiply the entire sum, which means we need parentheses to indicate that that sum needs to happen first before multiplying by 2. All right, in number 6, 7 less than 2% of a number. Well, 2% of a number is 2/100ths times that number, and 7 less than it happens when we subtract 7 from the result. In number 7, we're going to solve for the variable k. So we need to use the distributive property first to get rid of those parentheses. So negative 3 times k is negative 3k. Be careful with the next distributive. Negative 3 times negative 2 is positive 6. On the other side, 4 plus 2k. Let's clean it up. Left side, simplify. Right side, simplify. You can change the order if you like. And then we need to subtract 2k from both sides. And subtract 6, and that gives us negative 2. And then dividing by 3, k is negative 2/3. In number 8, we have a fractional equation. The LCD of all the denominators, 5, 3, and 15, is the least common multiple of all, which is 15. So we're going to multiply both sides by 15 here. Now with multiplication, you can write it on either side. Don't do that with exponents. Exponents are always written on the right side. All right, now let's distribute. 15 times 2/5. So 1/5 of 15 is 3, so 2/5 would be 6 times m. Now distributing to the next term, 1/3 of 15 is 5, so 4/3 is 4 times as much, or 20. On the right side of the equation, we distribute as well. 15m, and 1/15 of 15 is 1, so 2/15 of 15 is 2. Now we need to move the m's to the same side. We can certainly subtract 6m from both sides. That'll give us 9m minus 2 on the right. And then adding 2 to both sides, and then dividing through by 9. Right, we've got to undo the times 9 that's hanging off of the m. So dividing by 9 gives us 22/9. All right, in number 9, this is an expression where you have to do the exponentiation first. So if you want to think about what the exponentiation means, that's 2a to the fourth times 2a to the fourth times 2a to the fourth. Now remember, I'm not necessarily going to write it out, but that a to the fourth is a times a times a times a. Same with this one. Same with this one. So if we think about the number of factors that I've highlighted so far, there's 4 factors multiplied together, 8 and 12. And then this one represents another 5 factors, so that's 17 factors. And then 2 times 2 times 2 is 8. All right, let's check out number 10. In number 10, similarly, we need to do the exponent part first. So that's negative 6x to the fourth y to the 7th times negative 6x to the fourth y to the 7th. You don't have to write it out, but you do have to visualize it. All right, so what have we got? Looks like we've got, if we just look at the numbers, we have a negative 6 times negative 6 is 36 over 4. And then we have another fraction where we can just think about the x's. So let's highlight all the x factors. And we've got x to the fourth times x to the fourth. Now that's not 4 times 4, but remember each x to the fourth is x times x times x times x. So this one is also an x times x times x times x. So there are 8 factors of x. Downstairs we have 8 factors of x as well. All right, now let's think about the y factors. So y to the 7th times y to the 7th. If you think about that all stretched out, that's a total of 14 factors of y. And then downstairs we have 1. All right, let's do a little simplification. 36 over 4 is 9. X to the 8th over x to the 8th is just 1. And y to the 14th, which is y written out times itself with 14 factors, divided by 1 factor, means that we undo one of those multiplications. So now we have 9y to the 13th. All right, let's check out 11. Perform the indicated operations. So 5w minus 3 squared means 5w minus 3 times 5w minus 3. Don't distribute the exponent. Exponents don't distribute over subtraction. So if you like, you can make a box. So 5w minus 3 times 5w minus 3. You can do that whenever the factors that are being multiplied together are a binomial or a trinomial, that is to say that they are added or subtracted. So now we have 5w times 5w is 25w squared. 5w times negative 3 is negative 15w. Same result here for that product, and negative 3 times negative 3 is positive 9. Now we just simply need to add all of those factors together, so 25w squared. Combine those, and we have minus 30w plus 9. Make sure that you put it in descending powers. That is, you want to write the squared term first, followed by the w term, followed by the term with no variables. All right, we're going to do the next one in a very similar way because we have a trinomial times a binomial. u minus 3, u squared minus 5u plus 4. U squared times u is u cubed. U times negative 5u is negative 5u squared. And u times 4 is 4u. On the bottom row, negative 3 times u squared. And then we have a positive 15u and a negative 12. Again, let's think about our like terms. We've got a pair of like terms there. And we've got another pair right here. So as we write out our result, let's combine them. We're going to start with the u cubed because that's the highest exponent on the variable. The next term is a combination of the negative 3u squared and the negative 5u squared, which is negative 8u squared. The next term is 15u plus 4u, which is 19u, and then minus 12. There's our final answer. All right, let's check out the last one because it looks similar, but it is not similar. One thing that I want you to notice about it is there's a minus sign in between those. So we're not multiplying them like we did with the last two. That means we're not going to use that box method. What we're going to do is we're going to subtract by adding the opposite. So change to adding the opposite. Now we can add together our like terms. 5c and negative c are 4c. And then we have a negative 9c and a plus 2d. That's going to give us a minus 7d. Make sure that you don't confuse subtraction with multiplication, right? We need to distribute that minus sign, but there's still a plus, right? Because we're changing subtraction to adding the opposite. All right, let's move on. Number 14, 25n squared minus 9. What you'll notice is that we have two perfect squares here in between a minus sign, or with a minus sign in between them. So the two factors are 5n plus 3 times 5n minus 3. We can certainly check the result by multiplying our two binomials together. That's 25n squared plus 15n minus 15n and minus 9. What you'll notice is those middle terms combine together to give you 0. So we have 25n squared minus 9. All right, let's check out the next one. This is two terms, but both have a k in them. There's a typo on this one, it looks like. That should be 12k squared minus 30k. Sorry about that. So if we factor out, we're going to have a common factor of 12 and 30 is 6 is the largest common factor. And then times k, because both terms have a k in them. And then that's times k minus 5. Oops, 2k minus 5. We can always check by distributing. That's something that I want to do mentally each time I write down my result. Help me catch those errors that I make. 6k times 2k is 12k squared. 6k times 5 is 30k. So there's our final result. Our two factors are 6k is one factor and 2k minus 5 is the other. Binomial factors or trinomial factors need to go in parentheses, but a monomial factor doesn't need them. All right, last one is a trinomial, 2y squared plus 7y minus 4. So if all terms are present, we're probably going to use that AC method to factor this quadratic equation. So our a times c is 2 times negative 4, which is negative 8. Let's list some factors of that. Factors of negative 8 are 1 and negative 8. I like to start with 1 and the number. Now, think about what those add up to. 1 and negative 8 add up to negative 7, so we're real close. We just have to change the signs of the two factors. Negative 1 times 8 is still negative 8, but it adds up to positive 7, so this is the pair that we want. Now I'm just going to make a box, and I'm going to write 2y squared in the top left, negative 1y in the top right, 8y in the bottom left, and minus 4 in the bottom right. So we just split that 7y up into 8y minus 1y. Now let's take our top row and factor out the greatest common factor. That would be y. And then let's do the same for our bottom row. 8y minus 4, the greatest common factor is 4. Now we factored out a positive because the starting term, or the leftmost term on both of those, is a positive number. If we do the same for the left column, whoops, if I highlight that you can't see it, but the left column would be this part right here, 2y squared plus 8y. 2 times y is the greatest common factor, and the greatest common factor of the right column is -1. You can certainly check that by multiplying to make sure that all of the boxes have the correct result in each. So there's our two factors, y plus 4 times 2y minus 1. Doesn't matter which order you write them in. All right, 17 and 18, we're directed to solve the equation, which means something different from factoring. We're going to find the value of x that makes, or values of x that makes this equation true. So we've got to do a little bit more. For 17, we need to move all the terms to one side of the equation, and we need to write them in descending powers. So x squared followed by x followed by no x's. And we need to have that 0 on one side. Once we do that, we can factor using the AC method. A times c is 3 times -6, which is -18. So factors are 1 and -18. Well, that adds up to -17, so that's not the right one. We're looking for one that adds up to -7. So 2 and -9, there's our pair. So 3x squared plus 2x minus 9x, and then -6. GCF of the top row is x, of the bottom row is -3. The left column, 3x, and the right column, 2. So we have x minus 3 times 3x plus 2 equals 0. That's going to give us x minus 3 equals 0, or 3x plus 2 is equal to 0. If we add 3, we get x equals 3 for the first equation. And then if we subtract 2 and then divide by 3, we get -2/3 for the second. It's nice if we can write a result as a solution set. That gets the squiggly brackets. It's not an ordered pair or a point on a graph. It's two values for x that satisfy, each of which satisfies an equation. So they make up a set, which is noted by those squiggly brackets. All right, let's check out 18. 18 is actually easier. Why is it easier? Because we already have it in factored form, and one side is already 0. So if two factors multiply together to give a result of 0, that means that one of the factors is 0, or the second factor is 0. So if -5 times c is equal to 0, -5 times what is equal to 0? 0. So c is equal to 0. You can divide 0 by -5, but you must simplify it. 0 divided by -5 is 0. Then on the right equation, we can subtract 7 and divide by 3, so we have -7/3. So our solution set looks like this. The values -7/3 and 0 are both in the solution set for the equation. All right, 19, we're simplifying a radical expression. So we want to think about those perfect squares that divide evenly into 48. What are perfect squares? 1, 4, 9, 16, 25, 36, etc. Now, two of those numbers do divide evenly into 48, aside from one, which divides evenly into every whole number, 4 and 16. But let's pick the bigger of the numbers because it will help us simplify this quicker. So the square root of 48 is the square root of 16 times the square root of 3. And I just brought the 5 down. There was a times sign understood between the 5 and the square root symbol. The square root of 16 is 4. So we get a result of 20 times the square root of 3. Now let's do number 20. We have the square root of a fraction, so we need to distribute the square root to the numerator and to the denominator. Now, we're going to need to rationalize this, but before you do this, make sure that you simplify any square roots that you can. So that's 4 over the square root of 13. Now we're going to take our 4 over the square root of 13 and multiply it by the square root of 13 over the square root of 13. And that gives us 4 times the square root of 13 over the square root of 169, which is 4 times the square root of 13 over 13, or divided by 13. Do we need to know that 13 times 13 is 169? It's helpful, but the square root of 13 times the square root of 13 is just 13, regardless of the fact that 13 times 13 multiplies together to give you 169. All right, let's find slope in the next. To find slope of a line given 2 points, we're going to use that slope template. The top has the change in the y value. So what are the y values? They are 4 and -1. Notice that I used the point on the right first. So let's do the same with the x's when we write the bottom. That's going to give us 2 minus -5. All right, 4 minus -1 is 5. 2 minus -5 is 7. So we get 5/7. I want you to notice what would have happened if we did this backwards. We did the same slope template, but we did the subtraction in the other order, -1 minus 4 and -5 minus 2. Well, that would have given us -5 on the top and -7 on the bottom, and a negative divided by a negative is a positive, so the result is exactly the same. We just have to be consistent in the way that we subtract on the top and the bottom. All right, let's move on to number 22. We want to write the equation of a line, and there's a hint here. It's going to look like y equals mx plus b when we're done. But since we have a point and we have the slope, we're going to use that point slope form. Y minus y1 equals m times x minus x1. So y minus the y value of the point, which is 1, equals the slope, -4/5, times x minus the x value of the point. So now we have y minus 1 equals -4/5 x, and then 1/5 of 15 is 3, so 4/5 is 12. And a negative times a negative is a positive. Be real careful when you distribute. Now we're going to add 1 to both sides. That gives us y equals -4/5 x plus 13, and that's our final answer. In 23, we are graphing a line. Our slope is 4/3, and our y-intercept is 0, -2. So 0, -2, and then from that point, we're going to rise 4 and run over 3. Rise 4 and run over 3. We can do the same in the opposite direction, fall 4 and left 3. And what we want to do is extend that line all the way to the end of the grid and put arrows on the end. I don't care too much about your line being ruler straight as long as you make these points obvious. All right, now number 24, solve the system by graphing both equations. So we're going to graph 3x minus y equals -1. We need to solve that for y. So y equals -3x minus 1. And in order to solve for y, we need to divide all terms by -1. So that's y equals +3x plus 1. All right, that is going to give us a y-intercept of 0, 1 and a slope of 3, which is 3 over 1. So up 3 for every over 1. So we want to graph that line, and now we're going to graph the second line. 2x minus y is equal to 1. So again, subtract the x term off, and divide by -1. That'll give us y is equal to positive 2x minus 1. So that has a y-intercept of 0, -1 and a slope of 2. So that's up 2 over 1, up 2 over 1, up 2 over 1. Looks like we're getting farther away from the other line over in that direction. So down 2 and left 1, down 2 and left 1. This one's going to be hard to pinpoint unless you're really careful. So I guess we probably should check this one. Looks like that's the point right there. So that is the point -2, -5. So we think that's the answer, but let's go ahead and check it. Let's check it in this first equation. 3 times -2 is -6, minus -5 means +5 equals -1. That one checks. Second equation, 2 times -2 is -4. -4 minus -5 would be -4 plus 5 equals 1. That one checks. It's really important, especially when you're maybe struggling a little bit if the lines are kind of very close together there and it's hard to see the intersection point. That may help us find it a little bit more carefully. All right, now let's do one more, solve using an algebraic method, not by graphing. Now this one, I think, is set up very nicely for that addition method. 2x plus 6x is 8x, y plus -y is 0, 8 plus 12 is 20. So 8x equals 20, and x equals 20 over 8. We always want to reduce that. That's going to be, what, 5 over 2? If we divide numerator and denominator by 4. And so let's plug that into either one of the two equations. I'm just going to pick the top one. So 2 times the x value plus the y value equals 8. 2 times 5 halves is 5. So 5 plus y is equal to 8. Subtracting 5, that's 3. So it looks like we've got a solution of 5 halves, 3. And you could certainly do that one by substitution if you wish instead. Well, that's it for the solutions. If you have more questions, please make use of the sessions that we'll have in early August before we come back to school.